I welcome you all to another video about RDD operations. So here we'll talk about the RDD operations and all the transformations that could be done. What are the lazy evaluations, what is map, reduce, filter, flat map, reduce by key, and all that aspect, just to get a high level idea. And we will also try to understand what happens behind the scenes when you invoke these methods. Okay, so RDDs, as we all know, resilient distributed datasets, we have already discussed a lot about these in my previous tutorials. So just in case if you're not sure what this means and everything, make sure that you watch the previous videos that covers these topics in detail for proper understanding and abstraction. And this doesn't have to be specific to like any language specific. This is more like a theoretical stuff. Later on in this part we will cover more language specific things, but these are all conceptual things, so that's why I'm sticking to using Scala. But the same concept goes with Python, and we have seen some demonstrations on equivalent Python codes and all. With that being said, let's get started. So RDDs provide a powerful abstraction for processing and managing data across clusters in distributed fault-tolerant way. They support two primary categories: transformations and actions. Now, what is transformation? Also, these concepts we will be using in our upcoming lectures. So I hope you get a proper understanding of this. Feel free to ask questions if you have any. So what is transformation? So transformations create a new RDD from existing ones. However, they don't compute their entire results immediately. This is one of the coolest properties of Spark. So whenever I do a transformation, like let's say if I do val maybe sum equal to nums dot reduce, and then I just do underscore plus underscore. So this won't be actually, let's say nums, and if I do nums as val nums equal to spark dot spark context, actually it's giving me right results. So this thing won't be computed right away. It will be stored in the memory, and not in the memory, it will be stored as a reference. But once we compute the sum, then only this will be computed. Okay, so will be applied, only execute them when an action requires a result. Okay, so that is what this is known as lazy evaluation. These are some transformations like map, filter, flat map, and reduce by key. Only when the actual results are invoked, then only these things would be computed. Okay, and actions include reduce, collect, count, and take. So reduce, as you know, like it, because it will definitely require the actual processing. So for that we have all these summations and additions and everything. Collect helps us to convert the lazy stream or lazy evaluation into active list. So let's say you want an array, then you can just do dot collect and then call that method, and we have seen this. And let's just see some examples. So nums equal to spark dot spark context dot parallelize, let's say 1 to 10. Okay, for simplicity purpose. And then what we do is we just do we will see examples of these, although we already have seen. But yeah, I think Copilot is already giving me good suggestions. So sum and nums dot reduce underscore plus underscore, and if I go and run this, so you can see that 1 to 5 sum is 55, and that's what it is giving me another output. Now we will see what does the collect do. So let's say currently if I just do println nums is, and let's say I just do nums. Okay, and if I run this one, wait, something is wrong. Println, okay, let me run it again. So you can see that it's saying nums is parallelized collection RD0 and all this thing, right? But we are not actually getting the actual array. So what we do is nums list equal to nums dot collect. Okay, and then if I do nums list, and now let's see what we get as an output. So wait, I think next time I'll just go to SPT shell instead, because Yeah, this recomputation takes decent amount of time. Okay, let me just go to SPT. So yeah, I mean, not exactly. If I see, it's saying array of int, right? And this one, if you see, this is RDD of int. So the conversion of RDD to a array, which is an active list, meaning that this won't be computed on the go, but this will force it to compute. That is what the collect does. Okay, and if we go here and instead of this, let me do a dot make string operation. So I hope this should work. Actually, that non-string may be just pointing to the direct address, and that's why it will show me in that address format that we saw. However, this one should show a bit. Yeah, see, this number is coming, but if I do it as nums, I don't think we have any such method on this. Yeah, so it's complaining, right? Because this list is not computed. I mean, it will initialize this. It won't be this nums would not come into the existence until this call, because it's lazily evaluated. That's the importance of transformations are only evaluated when they need it. However, the second one will definitely work because now it's an active list, because collect will run all this and collect all the data. Okay, similarly count will count the number of elements, and take will, let's say we want only first 5, so I can just do take, and then I can just dot
It's 2030.
Yeah, so if I take only the first 5 elements, so I can do num sum until 5 elements is, and then I can just duplicate this till this. Okay, so you can see the difference, right? First 5 element 15, all elements 55. So that is what take helps you. You can take n number of elements, and again this is also computation, so it makes it active. So I hope you are getting it. What is the difference between lazy evaluation and active evaluation? Lazy means that, okay, I have something, I will just store a pointer or store a reference saying that what does it mean, like let's say 1 to 10. So this nums would be assigned with 1 to 10. I mean, not assigned, but it will be formulated like 1 to 10, and whenever num starts some activation or action is performed, like reduce or like collect or like take, then only those active. Like if I do nums dot take 5, then only the first 5 element would be, because here I did the reduce, so it's computed, it has done all the computation. However, if I do take 5, then it would do only until 5, and rest all 5 will remain, like 5 to 10 would remain in the lazy state, like that. What is the advantage of this is that you don't have to store all this in memory and do unnecessary computation, and do the computation only when it is required. Okay, so that is what this whole thing discusses about transformations and actions. Okay, so all transformations in Spark are lazy, meaning they do not execute immediately, right? This statement won't execute immediately, maintains a lineage graph, and this is what I mean, the reference thing that I was talking about. You, in more technical terms, you can say this as lineage graph. Okay, so lineage graph, basically this is like a reference which stores information what this is supposed to do and all, but that's all. It won't compute or get any additional memory unless action is invoked on that. Okay, lineage graph of all transformation that apply to initial data set. When an action is called, Spark uses this lineage to optimize the execution plan and run transformations efficiently, minimizing resource usage. For example, if map transformation is followed by reduce action, Spark understands that only the final reduce output needs to be returned, not the intermediate results. That is again for the optimization of the intermediate parts and extra memory usage and all that. but yeah, that's the important aspect. Okay, now RDD persistence. Yeah, so in previous video we talked about how caching, I mean it might be confusing, so I just wanted to repeat. Caching is basically persistence with memory only method. Okay, because caching is nothing but caching the RDD in the memory. However, persistence could be disk memory, disk and I mean disk only. Actually this is not disk memory but disk only, memory only, and I guess disk and memory. Okay, so let me bring it down to the new line. Okay, so caching is a special case of persistence, you can say, where it's memory only. Okay, so by default recomputes each time action. However, for the cases when RDD will be used multiple times, persistence or caching can improve performance by storing the RDD in memory. Okay, so this is one important thing, and that's why persistence and caching, because let's say if you are invoking this RDD again and again, then in that case we just use caching and that will be enough. We don't need to put it in persistence and do I mean we can cache or persist it, and we don't need to recompute it all the time whenever it comes from the disk, because in the disk these disk only, memory only, and disk and memory things that will anyway be variable. So the caching requirement is, instead of looking again and again, this particular nums would basically be cached into the memory, and then it will be reused for faster access and everything. Okay, so that is what it is. And please don't confuse it with the operations. Like if I do, like let's say val x equal to nums dot count. Okay, so this doesn't mean that count operation won't be performed again. Count would be performed, but since it's a lazy evaluation, so nums will be computed and the count will be performed. But if I do nums dot persist or nums dot cache, and then I do val y equal to nums dot count, so again count will again be recomputation of count will happen. Okay, so let me so what this means is, like let's say if I have 1 2 3 4 5, so count will happen to 1 2 3 4 5 and the result will be 5 in both the cases. However, in the first case this 1 2 3 4 5 will be again evaluated, because this will only be evaluated when some action is taken, right? In our case actions are what we had, like reduce, collect, count, take, right? So this 1 2 3 4 5 would be only computed, as we know rule of thumb is transformation is a lazy evaluation, right? Evaluation, and only when action takes place, only when action takes place is when transformation goes into active state. Okay, so every let's say if I assign it to nums, then every time I perform an action, like let's say count or take or collect, this will trigger this nums, and it will go through each of these and actively evaluate. First it will compute the active evaluation of the nums, and then it will perform the necessary action, for example count and so on. However, when you do a persist, when you do a dot persist, that means this particular thing, this RDD is persisted into your memory. Okay, and that's why it is faster to access. Oops. Yeah, that's why it is faster to access. So now whenever we perform dot count or dot collect or any method for sake, then it will be counting and accessing it in a quicker way. Okay, so that is the role of persist or cache. Okay, don't confuse that it would not actually, like let's say if the count has happened, so it will immediately use that result and not recompute it. No, count will still be recomputed, but this will be computed on a RDD which is stored in the memory. There's a difference. Okay, so one way would be, let's say if I do 1 2 3 4 5 1 2 3 4 5, and let's say count resulted in how many, 5, right? So don't think that when the next invocation happens it will take directly from memory. Okay, it won't take this count result. Okay, let's say it is count result, so it won't take this result from the memory, rather it will recompute everything, but this time it will take RDD from the memory instead of reading it back from its origin and all. Okay, so that is the only difference that caching or counting persisting does. Okay, so I hope this is very clear, because this is a very important concept, and initially I was also very confused about this, like 1 2 3 4 5, that means if I perform an action, that action result will be cached. But no, that's not the case. Actually, action will be re-triggered, but the RDD will be persisted to the memory. Okay, retrieved, reduced by key versus reduce. So reduce applies to a function across, reduce by key is a special method where you can you will get a, like, let's say you have some key comma value and your RDD is like this. Only for these kind of RDDs you can perform reduce by key, and you can do any kind of transformation like concatenation for all specific strings. Like, let's say you have maybe name is Sam, and maybe city lived is Delhi, and then comma again Sam, and then next city lived is Hyderabad. So you can transform this by reducing it to key and concatenating the results, and then you will be basically reduce by key, and then you will do plus and dash plus and this. So this will result into Sam, Delhi, Hyderabad. Okay, so something like this. So you can do any kind of operations. That's the only difference between these two. It could be only operated to that specific case. Okay, so lazy evaluation we already discussed in details. Let me just go through in case if I missed something. Spark maintains a lineage graph. I think we already discussed this. By default, Spark recomputes the transformation of action called. However, case where RDD will be used see this line is very important. Where RDD will be used multiple times, persistence or caching can improve the performance by storing RDD in memory. Currently, RDD is not stored in memory. However, when you apply this will be stored in memory, and when computation happens, it will still happen. It's not like computation would be cached or persisted. That will still happen, but the thing is, RDD will be stored in memory, so access to RDD will be pretty fast compared to running it. Recalculating the RDD each time the action is performed, speeding up the repeated computation significantly. The persist method allows flexible storage options. Memory only, which is the cache. So persist with memory only is the default way, which basically is the cache. Okay, so as we discussed here, how caching is the subset of persistence. I hope you got it. So when you apply persistence with memory only, that is what caching does. Okay, disk storage is when RDD is too large. So sometimes your RDD could be way too big and it cannot come into the memory, and then you go for the disk storage where it will store into the disk and then it will read it on demand. Okay, keeping it accessible across all clusters. Replicated storage across multiple nodes and replicated, and there's one more disk and mix of disk and memory. So it basically you specify disk and memory, and when memory runs out, it will automatically go to disk. Okay, optimized Spark enables scalable processing and distributed. In Spark, persist and cache are both stored, allowing for faster access. RDD, while there are similar there are some differences. Cache method is shorthand for persist with specific storage. By default, cache stores the RDD in memory only. If the RDD is too large, Spark may recompute parts of RDD that doesn't fit in the when they are needed. Okay, so in case if it's too big, then Spark will do all these recomputations and everything. Okay, and this is a very simple example, flatMap and all. So if we cache it, it will store this RDD in memory, and then count will become significantly faster. Okay, flexibility compared to cache, as it allows you to specify different storage levels. For instance, you can store RDD in memory only, on disk, or a combination of both. Some common storage level includes memory only, memory and disk only, memory only serializable. So SER basically refers to serialized format, which takes less memory. Okay, but this because you're serializing it every time, this will take a little more time compared to actual operation, but it optimizes your memory usage. So this is how you specify like storage level, memory and disk. However you want to specify, you can specify it like this. Okay, and memory only is very clear. Storage in memory and disk is, and spills to disk if memory is insufficient. disk only, stores only on disk. Okay, if RDD is too large, fits entirely in memory, Spark avoid recomputation by reading parts of RDD from disk. Okay, so here is some difference. Usage, shorthand. Yeah, basically cache is nothing but persist with memory only. I think we discussed it enough. Yeah, you're supposed to use cache when you want faster computations and you are sure that your data RDDs are small in size, they are not too big, and you use persist if you want to control more of a storage level of RDD might be too large for memory and need disk-based persistence. Okay, so convenient shortcut for in-memory usage by persist offers a broad range of operations for handling storage. Okay, when reduce AAB is called, performs the following: it reads the data from the text into the lines, it applies map transformation to calculate each line resulting in line length. So let's quickly see this. So I'll just do lines equal to spark context dot read text file and source assets. Where is located? Source asset sample.txt txt. Okay, and then we will do val line length equal to lines dot map underscore dot length. I mean, this is equivalent to this line only. Okay, so what we are doing is we are capturing all the lines and then getting their lengths, like how many characters in that particular line contains, and then we will do line length dot persist. By default this is equivalent to cache only, and then we will just invoke val total lines equal to line length dot count. This is another way to count number of lines in a text file. Okay, ln s total lines equal to line length, total lines. Okay, so let me run it. Yeah, so total lines is in 3. Let me just sample.txt. Yeah, we have 3 lines, right? So anyways, that is one part, but let's understand. So line length, when we define lines.map as dot length, which is underscore dot length, does not compute it immediately. Okay, and by the way, just in case those who are not familiar, so what we do is we have an anonymous function saying that map is for each line. We can actually, let me I'm not sure if you are well versed with it, but let me explain it to you just in case. Feel free to skip if you completely understand this line. Okay, so when I do val, okay, this basically means for each line give me line dot length. Okay, like if there is no specific property, then for shorthand notation we just replace it with underscore dot any property. Like let's say if we wanted to add some extra things, then we might have to do, like let's say we wanted to do some kind of computations, then we could have done it something like this. Okay, +1 or val specific line length equal to line length +1 -4, like any kind of manipulation, and then we could have specific line length we could have returned. So basically this is an anonymous function. However, since our transformation was fairly simple, so I just did underscore dot length, which basically translates to val line length equal to lines dot map, for each line give me its length. Okay, these two are equivalent statements only. So yeah, it's saying Spark does not compute it immediately, instead it waits it until. So this is a transformation. Okay, dot map. Remember we had discussed 4-5 types of filter, flatMap, reduceByKey. Similarly, this is a transformation, so it won't recompute it immediately. Okay, only when an action is invoked, which is again action chart you can see here, reduce, collect, count, take. Only when one of those is invoked, then only it will compute it. Okay, this enables Spark to optimize execution and avoid unnecessary computations. When reduce AAB is called, Spark performs the following: it reads the data from text into the line, and it applies map transformation to calculate length of each line resulting. Finally, it reduces the value by summing up and getting the total length. Okay, and of course we did not use reduce, but we just used count. But why would, okay, I think okay, for total lines and for total length we can do total length equal to line length dot reduce, and we can just do underscore plus underscore. Okay, total lines and total lengths. Okay, and let me just run this just to be sure. Yeah, so when we do persist, this means that now this RDD will be persisted in memory, and now every computation that happens will be taken from in memory instead of going again and again. Okay, since the first time line was called before reduce, the compute line length RDD would be stored in memory. After that, when persist is applied, line length before action, Spark stores the compute length in memory. The stored RDD values allows for future transformation actions and length and everything, and bypassing the need to recompute this again and again from scratch. Only affects subsequent actions. The initial reduce action still performs. So let's say if I just do something before this persist, like let's say if this count operation was before persist, then that means this whole step would have been computed again. Okay, so that is very important. But when I do persist, then this time it will take from in memory. Okay, and if another action line length dot count is called after the reduce, Spark will use in memory line lengths, avoiding the need to reread the data.txt and recompute the lengths. Okay, so in summary, persist saves line length in memory after the first computation triggered by this. Spark will reuse in memory database, making future operations faster by avoiding recomputation. The reduce itself still performs the computation in full the first time, but subsequent actions are faster due to caching. Okay, so that is whole, and let me see. Yeah, total length is this and total lines are this. Okay, so that is all about RDD operations and transformations and actions. I hope you are clear with this. I hope you got a thorough understanding of this, because this is very important, and this will form the base for a lot of upcoming actual concepts. So yeah, that's all for this video. I hope you liked it. In case if you have questions or any comments, feel free to drop in the comments. In case if you have any suggestions, anything you want to share with me, I would be more than happy to incorporate that. And yeah, that's pretty much. Thank you very much, and I hope you are all having a great day, and happy Diwali.